Okay, so let's start. It's already 4:08. Okay, so in the last class we discussed about this, right? The about the common salt. Common salt is what? Common salt is NaCl. My voice is audible, Safia?
Yes, ma'am.
Okay. So what is common salt? Common salt is NaCl. NaCl is nothing but sodium chloride, and this is categorized into three types. Like Na basically is the mixture of three things: chlorine gas, hydrogen gas, and NaOH. OH is basically hydroxide, so we call it as alkali. Now, this was the diagram we discussed. These two are electrodes, and the minus one we already know it's a cathode, and the plus one we all know it's a anode charge, है ना? So in the cathode one, why there is a hydrogen gas and sodium hydroxide, and in the side of the anode, why there is a chlorine gas. And here in this beaker we are taking a brine solution. Brine solution basically called NaCl plus water. Brine is a mixture of salt plus water. Okay, just yeah. So NaCl we all know that NaCl consists of, matlab Na is the like charged particles of two things. One is Na plus, another one is Cl minus, right? And water we all know it's H2O. So in this beaker we are taking one brine solution. Now, why am I writing these two in the side of cathode and why chlorine gas in the side of anode? So we discussed that Na is what? Na is plus here. It needs one electron. So it will take it from where? It will take it from cathode, because minus will attract towards positive. The opposite charges attracts each other. है ना? So this one is what? Na is plus. Na is plus. It will take charge from minus cathode. So that's why from here it will take charge from this side. So if it will take charge from this side, then what will happen? It needs one electron. So we already give Na one electron, Na plus one electron minus. It's giving Na, which is a solid. So what will happen if this my Na becomes solid? So after Na is nothing but sodium. Huh? So when sodium becomes solid, it will react with water. So after reacting with water, it will in the product side we will have these two things. One is sodium hydroxide, another is what? Another is hydrogen gas. Okay, so that's why here I am writing hydrogen gas and sodium hydroxide. Now, why in the side of anode? Anode is plus. And sorry, anode is what? This one is Cl minus. So if minus is there, then it means it's having one extra electron and it wants to donate that electron. Okay, so here Cl will donate this electron to Cl minus, Cl2 plus 2 electron minus. So this is Cl2 is nothing but a chlorine gas. Now chlorine gas will start rising in the side of anode. So here that's why in the side of anode the chlorine gas, and cathode is nothing but the this one, the hydrogen and sodium hydroxide. Okay, so now we will learn about what are the uses of these three. Let me write it here. Bleaching. No, just a minute. Yes. Where should I write? Okay, here, this side. Now, what are the uses of these three? These three means the hydrogen gas, chlorine gas, and NaOH, sodium hydroxide. Okay, here the NaCl is what? Chlorine gas, hydrogen gas, and NaCl. So now we are looking at what are the uses of these three. So first of all, we will learn about the hydrogen gas. Okay, H2. So what are the uses of H2? The uses of H2 are in the refining petroleum, refining petroleum. Okay. The use of this one is in the is to refine the petrol. Due to with the help of the hydrogen gas, we usually refine our petrol. Now the second one is treating metals. Treating metals is also with the help of hydrogen gas we do. Third one is producing fertilizer. fertilizer is basically used in our field areas, है ना? Producing fertilizer. Okay. Now the fourth one is processing foods. Hydrogen gas helps in processing foods. Okay. Then what is this? Then in the welding also hydrogen gas is used. Where's Rudra? Okay. And the last one is production of hydrochloric acid, HCl. ठीक है. So the use of hydrogen gas is in these three. First is the refining petroleum. In the refining petroleum, hydrogen gas is used. Second is the treating metals. Third one is the producing fertilizer, processing foods, welding, and last one is the production of HCl. Okay. Now what is the use of this chlorine gas, Cl2? Do you know what is the use of chlorine gas? Any points up here? Any point that what is the use of the chlorine gas?
It's used for disinfecting water in swimming pools.
Yes, very good. It is used to get, and one more thing is like it is used to get smell of, it is used as the disinfectant, used to clean swimming pools also, है ना? Let me write it. It is used as what? As a disinfectant. So first of all, we learned about what is common salt. Then we learned about that how this is working, the diagram. Now we are learning the uses, because in the baking soda, like all the types of salts, obviously we have to learn about the uses. Okay, so one is it is used as a disinfectant. Disinfectant. Okay. Second one is what? It is used to clean swimming pool. Used to clean swimming pool. Swimming pool. What is the third one? Third one is used as an antiseptic. Used as an antiseptic. These point you have to learn. Okay. Used as an antiseptic, and the last one is used to produce drugs. Used to produce drugs. Okay. So these are the uses of chlorine gas. Chlorine gas is used in the disinfectant. It is used to clean our swimming pool, used as an antiseptic, and also used to produce the drugs. Chlorine gas. Now tell me the uses of sodium hydroxide. Any uses of sodium hydroxide? Yes. Any uses of sodium hydroxide, Safia? Do you know?
It's used to make bleaching powder, baking soda, and also for making salt.
Yes. So first of all is it is used to produce soaps. You know, used to produce soaps. Safia, you are of CBSE or ICSE board?
I'm from CBSE.
CBSE. Okay. Okay. So in school, how many chapters are done?
We've just done. I think we've done this chapter too.
What?
We've done the first chapter for chemistry, and we are doing this chapter right now.
Means this chapter is done in school.
No, like we are currently in the middle of it.
Okay. Okay. So first of all, it's what? It is used to produce soaps. Next is it is used to produce paper also. Sodium hydroxide. Third one is petroleum products, and then the third one is petroleum products, and the fourth one is artificial fiber. Artificial fiber. So the uses of these three are done. Means common salt is done. One more thing is there. That see, if H2 is there, Cl2 is also there, then we can also write the uses of HCl. Okay. So what is the use of HCl in cleaning? HCl is used for cleaning. Next is ammonium chloride. Ammonium chloride. Third one is it is used in medicines also. Okay. And the last one is cosmetics. Okay. So these are the uses of common salts. Now let's go through this note. See, common salt is, we already know it's NaCl. Common salt is formed by the combination of hydrochloric acid, which is HCl, and sodium hydroxide, which is NaOH. Okay, solution. See, it's written what? It's the common salt is formed by the combination of these two. So here I wrote, let's talk about the use of HCl also. Why? Because it's basically HCl means the hydrogen gas and the chlorine gas. Okay. So my common salt is the combination of these two things. Hydrochloric acid, HCl means hydrogen gas, chlorine gas. You'll also write the uses of the hydrogen gas, chlorine gas, as well as the use of this HCl. Okay. And the sodium hydroxide solution, it is the salt that we use in food. Common salt is what? Common salt is NaCl. Common salt we all use in our foods, है ना? Seawater contains many salts dissolved in it. It is obtained on large scale from seawater by separating other salts from it. It may also be obtained from rock salts. So NaCl are obtained from the seawater, also from the rock type of salts. Okay. Deposits of solid salt are also found in several parts of the world. Okay, so these large crystals are often brown due to impurities, which are known as rock salts. Rock salts are impurities types of salts. Okay, and the color of the rock salt is brown in color. And what is the next one? Beads of rock salts were formed when sea of biogen gas dried up. Rock salt is mined like coal. So these are giving the formation of the rock salt. Common salt is an important raw material for various materials of our daily use, like sodium hydroxide, baking soda, washing soda, bleaching powder, etc. Okay, so from this we learned key what is the uses of common salt and how to produce this common salt, from where common salt we are generally getting, and what is the diagram of this common salt. This is the diagram. Now, what is the next part? Caustic soda. See, here also it's given that this is my salt. It is divided into three parts. है ना? Hydrogen gas, chlorine gas, and sodium hydroxide. See, fuels margarine, ammonia for fertilizer. This chlorine gas is used in what? This sodium hydroxide is used in what? So these are what important products from chlor-alkali process. Here also that day I told that this is nothing but a process of what? Process of chlor-alkali process. Okay. Now what is this? This is also a, okay. So what is chlor-alkali? When electricity is passed through an aqueous solution of sodium chloride, means NaCl, that's called brine solution, which I've already taught you. It decomposes to form a sodium hydroxide. Okay, so this process is called chlor-alkali process. So in this, in the solution, we took a brine solution. Here there is a two type of electrodes that we already discussed. This is one is cathode, another one is anode. So here hydrogen gas, sodium hydroxide, and in the another one there is a chlorine gas. Okay, just a minute. Yeah. So this now you tell me common salt part is clear. Any doubt in the common salt? Yes, Safia. Any doubt? Any doubt in the common? What? What are you saying?
No, ma'am. I have no doubt.
Okay, no doubt. Okay, so you have to learn these three. The uses one. Okay, and the chloralkali is nothing but hydrogen. Chloralkali is nothing but what? Chalo. Now you tell me what is like chloralkali process. Come on, fast.
Yes,
Tell
ma'am.
me. What are chlor-alkali process?
Ma'am, process in which brine is separated
Mm.
into its components like hydrogen gas, chlorine gas,
And
and, and aqueous sodium hydroxide.
sodium hydroxide. Very good. So these three are nothing but chlor-alkali process. Now our common salt part is done. Next we will be learning, see here also, this is the diagram H2Cl2 NaOH. Okay, so now what is the next one? Next is bleaching powder. So these are what? These are the bleaching powder, right? Okay, so first let me write. So what was the formula of this bleaching powder? Formula of bleaching powder is what? Tell me.
Sodium
No,
sodium oxychloride.
sodium oxychloride. CaOCl2, right?
Calcium oxide.
Calcium oxide. Yeah, good. So the formula of baking soda is this. Now, baking soda is represented as this one. Okay. Now, bleaching powder is produced by what? Bleaching powder, it is produced by what? By the action of chlorine, by the action of chlorine on dry slaked lime, on dry slaked lime. Okay, so what is the definition of bleaching powder? Okay, and what is dry slaked lime? Dry slaked lime reacts with chlorine to form, to prepare bleaching powder. Just reverse of it. Okay, to prepare a BP, I'm writing bleaching powder. Okay, so here how bleaching powder we are getting. Bleaching powder, it is produced by the action of chlorine on dry slaked lime. And what is the use of dry slaked lime? Dry slaked lime
Ma'am,
with
what's
uh,
slaked lime is calcium hydroxide.
what?
Is slaked lime calcium hydroxide?
CaO CaOH twice. This is dry slaked lime. Correct. Sodium, sorry, calcium hydroxide. Yes. Okay. Okay. ठीक है. चलो. Let's start. So the you got this part na, ki it is produced by the action of chlorine on dry slaked lime. Now what is the reaction? See, we are writing, this is our dry slaked lime, CaOH twice calcium hydroxide. When it will react with the chlorine gas, it will produce CaOCl2 and water. And CaOCl2, calcium oxychloride, is nothing but a bleaching powder. So by combining the dry slaked lime with the chlorine gas, we are producing a bleaching powder. If we will combine the chlorine gas and if we will combine the calcium hydroxide, then what we will get? We will get bleaching powder and some water. Okay. So here also it's written, see, it is produced by the action of chlorine on dry slaked lime. It is represented as CaOCl2. This is CaOCl2 is the formula of bleaching powder. Though the actual composition is quite complex. This is what? This is slaked lime, calcium hydroxide, CaOH twice. It's combining with a chlorine, producing a bleaching powder and a water. Okay, so on standing for a longer time, it undergoes auto-oxidation, due to which bleaching action decreases. Now, later on, I'll discuss ki what is oxidizing agent, what is reducing agent. Okay. Chalo. So now this part you got na, ki how we are producing a bleaching powder with the combination of two things. One is nothing but slaked lime, and one was what? With the chlorine gas, we are producing a bleaching powder and a water. Okay, got it? Now, what are the uses? Anywhere, if you're faced out, ask me. Okay. So what are the uses of this bleaching powder? For bleaching cotton and linen in the textile industry, for bleaching wood pulp in the paper industry. In the textile industry, it is used. Textile industry, paper industry also we can write. Paper industry. Okay. What's the next point? Used for disinfecting drinking water to make it free from germs. Acha, baking soda, bleaching powder is used for disinfecting drinking water to make it free from germs. Means it helps our water to get purified. Okay? Used for disinfecting drinking water to make it what? To make it free from germs. Free, okay, to make it from I wrote. To make it free from germs. Okay. Now, what is the third part? Chlorine gas is a very, here now let's go through once for with the notes. It is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper industry. This bleaching powder is used. It is also used as a disinfectant for water to make it free from germs. It is used as oxidizing agent in many chemical industry. What is used an oxidizing agent? This bleaching powder is used as an oxidizing agent. Okay. Now, here Cl2, chlorine gas. Where is my chlorine gas? Yeah. if I am combining the slaked lime with a chlorine gas, so my chlorine gas is a very good oxidizing agent. Chlorine gas is a very good oxidizing agent. Okay. Now, do you know what is oxidizing agent and reducing agent? Any idea about it? Oxidizing agent and reducing agent. Oxidizing agent. So, what is oxidizing agent? Oxidizing agent is a substance that causes oxidation by accepting electrons. Okay. It is a substance that causes what? That causes oxidation. How it causes oxidation? By accepting electrons. Therefore, it gets reduced. That's why we say na कि it gets oxidized means it get reduced. ठीक है? Therefore, it gets reduced. Now, let me write about the reducing agent. Then you will get to know okay, what is the difference between these two. What is reducing agent? It is a substance that causes reduction by losing electron. Opposite. It is a substance that causes reduction. Reduction means reduced. है ना? Reduce is what? Reduce is by losing electron. Therefore it gets oxidized. Okay. So what is oxidizing agent? Is a substance that causes oxidation, means it gets oxidized, causes oxidation by accepting electron. And what is reducing agent? It's a substance that causes reduction by losing electron. So here my chlorine gas is a very good oxidizing agent. Chlorine gas is a very good oxidizing agent. It means that chlorine gas causes oxidation by accepting electron. Na plus Cl minus. Cl minus is what? Cl minus is having one extra electron. That's why it get reduced. Here where is it? This one. See, Cl minus is what? Cl is having one extra electron. So if it's having one extra electron, it wants to get reduced. It wants to, distribute its electrons. So here also it's making sense that in this one, Cl2 acts as a very good oxidizing agent. It means it's having extra electron. It wants to get reduced. So that's why it's written here. Therefore, it gets reduced. Okay, this part you got, that why Cl2 is known as oxidizing agent. Huh? Tell me, Safia.
Yes, ma'am.
This part you got, why chlorine gas is a very good oxidizing agent.
Yeah.
You shall explain me why. What?
It's because it is negatively charged.
What? Your voice is not audible properly.
Yeah, ma'am, because it is negatively charged.
So therefore it gets reduced, right? By giving its electron. So that's why it is a very good oxidizing agent. Now, these are the uses of what? Of this bleaching powder. And here also it's written that uses we already done. Now we will learn about the baking soda. So bleaching powder, you understood now how we will form a bleaching powder. We'll form a bleaching powder by combining a slaked lime. In one hand is a slaked lime, in another hand is a chlorine gas. If we combine these two, we'll get a bleaching powder plus some water.
Yeah, ma'am, does it need heat to react?
What?
Does it require heat to react?
Heat to react?
Yeah.
Come again?
Yes, ma'am, does it react in the presence of heat or without heat?
No, without heat. Obviously without heat. Okay. The heating process is different. Here we are just combining with this chlorine gas. Okay. When heating and all will done, then the hydrogen gas will produce. That process is different. But here we are not giving any heating. Here we are just combining with it with this chlorine gas. Okay, Safia? Am I audible?
Yeah.
Okay. Chalo, what is the next one? These types of bleaching powder. Okay. So these are the types of bleaching powder. The powder thick type of powder. Okay. So this part is done. Bleaching powder is done. Next we will learn about the baking soda. Now you tell me what is the formula of baking soda. This is my baking soda. Yes. So what was the formula of this baking one? It's what? Tell me.
Yes, ma'am.
What is the formula of baking soda? chemical formula.
uh,
That day you told, na?
yeah,
Okay, let me write first what? N. Now you can tell.
sodium hydroxide.
Sodium H against CO3. What is this?
Yeah, sodium hydrocarbonate.
We can also say sodium bicarbonate, है ना?
Yeah.
Yes, good. Sodium bicarbonate. Now, what's written here? Baking soda. Only the formation is written. Let me tell you here or here. Here only. Okay. So it is produced on a large scale by treating cold and concentrated solution of sodium chloride with ammonia and CO2. Okay, let me write it. It is produced on a large scale, means this bleaching pot, no, sorry, baking soda we are learning now. So it is produced, means baking soda is produced on a very large scale by treating cold and concentrated. You have to, go through all the reactions because every reaction is different. So it is pretty large scale by treating cold and concentrated solution of sodium chloride, means NaCl, with ammonia. Ammonia is NH3, with ammonia and carbon dioxide, CaRDIO. Only I'm writing the short form. Okay? With the carbon dioxide. Now, what will be the reaction? The reaction will be, it is produced on large scale by treating cold and concentrated solution of NaCl. Means obviously NaCl will be there. I'm writing the brine solution. Brine solution also consists of some water, है ना? I've told na कि brine solution is the combination of two things, NaCl and water. ठीक है? So here NaCl, water, ammonia, and the last one is carbon dioxide. So if we will mix all these four together, we will get what? We will get NH4Cl and NaHCO3. This is nothing but a baking soda. Oh, so the formation of baking soda is little bit tough. Not tough. This one was very straightforward and easy. Bleaching one. This dry slate with a chlorine will get bleaching and some water. And here in the baking soda, if we will combine some salt, water, just learn like this. Here salt and water means, okay, it's a kind of brine solution. Okay. Salt, learn only the brine solution. If you will learn this brine solution, then obviously you will get these two parts, NaCl and H2O. Now the third one is ammonia and chloride. I'm sorry, ammonia and carbon dioxide. It's also easy, ammonia, carbon dioxide. You will get this formula, NaHCO3 and NH4Cl. Okay, these two you will get. Now let's go through some wording. This soda commonly used in the kitchen. Obviously baking soda is used in our kitchen only. This is the type of a packet of a baking soda. So the soda we consume also, hai na? Our mother put soda in the food also. The soda commonly used in the kitchen for making crispy pakoras is baking soda. It is mild, non-corrosive base. It is major constituent of baking powder. Sometimes it is added for fast cooking. Okay. Chemically, it is sodium hydrogen carbonate.
Mom,
Huh.
how is it a base?
What?
How is it a base?
It is a mild non-corrosive base. It's a property of the baking soda that your baking soda is a mild corrosive base. Now you tell me, what is the meaning of the corrosive?
It means that it corrodes metals and it is reactive with metals.
Basically, here it's written it is a mild non-corrosive base, means it helps in the preparation of cakes. Okay, because we put
Yes,
baking
ma'am,
soda.
in the preparation of what?
Cake, CAKES,
Okay.
cakes. ठीक है? The mild non-corrosive. Okay. So what is the next one? It is added for fast cooking. Huh. We also add baking soda for fast cooking because do you know why? Because to make, do you know why? Because to make fluffy our dish more fastly. Okay, so it is added for fast cooking. It is also a mild non-corrosive base. And what is the last one? This is the reaction. NaCl H2O, carbon dioxide, ammonia, it's ammonium chloride, and the last one is sodium hydrogen carbonate. Okay, got it?
Yes, ma'am.
Non-corrosive means nothing but like it's not having the power to corrode. Non-corrosive means corrosion. Corrosion means what? That iron fillings gets corroded now if we kept the iron filling in the environment with the help of the water droplets, right?
So,
So here
ma'am, it means that it's just a weak base, right?
it's a just a
It's a weak base.
weak base.
Yeah.
Yes, it's a weak base. Let me write here, not having the power to. Okay. So now it's this part is done. It's a mild non-corrosive base. Why? Non-corrosive means not having the power to corrode. Means our baking soda is not having the power of corrosion. It's very weak. Okay. Now this was the reaction which we already did. The brine. Okay. Now you tell me what was the reaction. It was very easy. Chalo, come on fast.
Yes, ma'am. Reaction for what?
Reaction of this baking soda. Right now I told na ki some
For the
brine.
preparation of baking
हाँ
soda.
हाँ
Yeah,
हाँ preparation only.
it's sodium hydroxide plus H2O, which is brine.
Sodium hydroxide. Sodium hydroxide. Sodium
Yeah,
hydroxide. Why
sodium
sodium
hydroxide and
hydroxide?
water. Oh,
Now
sorry. I meant
हाँ
NaCl, salt
हाँ
plus water.
sodium chloride. Yes.
Yeah,
Sodium chloride
sodium
water.
chloride plus water plus
Hmm.
ammonia and
Hmm.
carbon dioxide.
And it's giving what in the product side?
It gives ammonium chloride and
Ammonium bicarbonate.
yes,
Sorry, sodium bicarbonate. Yeah, go
yeah,
ahead.
sodium bicarbonate.
Yes, very good. So done with this reaction. Very easy. Now you tell me
Yeah,
the
ma'am,
reaction.
I don't understand. Like, what's the
Hmm.
difference between ammonia and ammonium?
Which one? Where?
The difference between ammonia and ammonium.
Ammonia is NH3, ammonium is NH4. Okay, if you write that it's ammonia, it means you have to write the formula NH3. If it's ammonium, then you have to write NH4. Okay, ammonium chloride, you can't write ammonium chloride as NH3Cl, no. And you can't write ammonia as NH4, no. Ammonia formula is NH3 and ammonium is NH4. Ammonium chloride, NH4Cl. Okay.
Yeah.
Okay. Now you tell me the reaction of that one. The bleaching powder. It was very easy. Come on, fast.
Uh,
Hmm.
it's CaOH twice plus chlorine,
Hmm.
and it gives uh, Ca
Hmm.
CaOCl2 plus H2O.
Very good. So now you are done with these two types of reactions. Now what about that? That was also easy, na? That was full of the notes type, the common salt. Okay. Common salt is this one. Sodium chloride, water, sodium hydroxide, chlorine, and hydrogen gas. Okay. So these three reactions now you are done. The bleaching powder one, baking soda, and the common salt. Bleaching is CaO. Bleaching means slake lime, chlorine. Baking is brine, ammonia, carbon dioxide giving NH4Cl, matlab ammonium chloride. And the last one is this only, the baking soda. Okay, so you are done with these two, these three means. Now the last one is on heating it decomposes to give a sodium bicarbonate. See, if you will heat a baking soda, now the process of heating will come. Okay, let's say you are heating baking soda. Okay, on heating it decomposes to give sodium carbonate with the evolution of carbon dioxide. It will give what on heating? Heating, the symbol is this delta type. Okay, on heating it will give Na2CO3 plus carbon dioxide and some water. On heating, it will give what? Na2CO3 is sodium. CO3 means carbonate. Sodium carbonate, carbon dioxide, and water. Here also, see it's written sodium hydrogen carbonate is also an ingredient of acha. Sorry, this is the uses. Here it's written. In the following reaction takes place on heating. If we will heat this is the balancing one. 2 is here just for the balance. And HCO3, if we will heat it, we'll get a sodium carbonate, H2O, and the evolution of carbon dioxide. This symbol is for evolution. Okay, so this you will form. Now till this reaction you are done. Here after heating you are producing the sodium carbonate, water and carbon dioxide. Okay Safia?
Yeah.
Yeah, ठीक है. So bleaching powder is done. Only go through the uses because this you already know now. The reaction you already know. The baking soda reaction you already know. Only after heating you have to